Hi, everybody. Welcome to join hybrid serverless development using Quarkus session. So my name is Daniel O. I'm working for Red Hat as a technical marketing major. I'm specialized in cloud-native app dev and agile and DevOps practice with the lots of Red Hat technology and open source project. I'm also responsible for CNCF ambassador as well as the DevOps Institute ambassador in order to evangelize lots of cloud-native architecture and practice and application reference with many enterprise developer and also IT operation team. I recently published Practical Ansible, give some guideline how to automate the IT operation team's task and also developer activity for their daily work. Just feel free follow my Twitter and subscribe my YouTube channel, bit.ly/Daniel TV. There are lots of practical example, technical tips, and application development demo. Just feel free enjoy the watching that things. All right, move on. So in order to understand why we needed the Quarkus in Java to develop hybrid serverless application development, just take a look at that, where it came from, and then Java, where Java came from here. So back in 1995, Java was born, and then there are a lot of things came up at the moment. And then just a few years later, in 1999, there are perfect time to sell software hardware by many vendors to build up and spin up your infrastructure and to run the Java application on top of that. So, for example, we needed to half a million to start with the infrastructure preparation. Also, we need to spend more than $80,000 for each year to maintain application server and web server and database, including hardware, infrastructure, CPU, memory, etc. In an architecture perspective, there are one monolithic application architecture, which includes all functionality in a single application artifact, also known as a WAR file and ER file. And then the architecture focus on density, I mean high density to how many application can be running on the number of application server with the scalability. It doesn't matter the consumption of a number of the CPU memory and disk storage, etc., like a resource perspective. In the meantime, the IT trend and technology kept evolving from 1995 and recently. And back in 2006, Amazon served the first public instance like a virtual machine, which means that the startup company or even enterprise company really looking to Amazon provide a service without purchasing new infrastructure software, infrastructure hardware stuff. In the 2009, Java 6 was came up. There are a lot of big changes to develop enterprise application quickly, easily, like a EJB, Vim, etc. In 2013, Docker container and Kubernetes 2014 came up to change the world. The people totally moved forward to new immutable infrastructure to run your Microsoft application and cloud-native application. So according to new technology and IT trend, so in the infrastructure layer also changed that, which means enterprise doesn't need to purchase a new hardware to run your business application with Java, but instead they just consume and use public instance like Amazon, like Google, Microsoft, and then they just need to pay as the amount of the resource consumption, just like a pay as you go policy. And then this is the reason why more and more enterprise company looking for the resource management with a small memory footprint and a fast startup time. If you don't need it to your application, they should be terminated automatically, which means you reduce your cost at the end. But with this the changing IT technology, and let's take a look at that the Java architecture perspective. So we've got the microservice architecture with a 12 factor, which means that you can run your application functionality with a single application package, and you have a short time to change your application, like from months to days, and a small memory buffering, like 100 megabyte, and a startup just a couple of seconds to start like a Spring Boot application. The problem is the centerpiece of this architecture still Java has dynamic behavior, and then you can run it on JVM. This is not a perfect architecture to optimize immutable architecture like a Kubernetes and Linux container. There's no change at all. The reason why the design perspective of Java. So Java is designed for high performance running on your application. There is no stop, no terminating, except for some hardware or software upgrade or patch or bug fix, and which means your application should be running on all the time, like a 24/7, even if the application doesn't need to serve all the time. So memory buffering, which means you need to spend lots of money to have that kind of buffering, like a heavy resource management, like a CPU memory. You need to spend a lot of money to do that, and also the design to be long learning process and 24/7 and no exception to that, and scalability, no scalability, but a little bit more scale up and then high scalability. It's also much expense of startup speed. Sometimes you need to spend about 5 minutes to start your application. Maybe that can be happen once a month or once a 6 months. Doesn't matter. But now we change it to microservice application and cloud-native application architecture and the technology stack. You could deploy application feature and bug fix or improvement and enhancement every single day, or even 10 times, maybe per day. So startup time and learning process is the good benefit or feature of this era. And one more thing, Java was really great for the back in decades ago with the rich dynamic behavior, beautiful mutable system. You can package your immediate file, also known as bytecode, and then you can run that bytecode to any application server across a web architecture like a World Wide Web and a web browser and etc. But this is not particularly matched to immutable infrastructure like a container, Linux container technology, and Kubernetes. So just imagine that you have one same application and one-time packaging, but you need to deploy 1,000 times on your cluster and Kubernetes or even public manage this platform. Same application, high scalability and high performance, and need to start up fastly and a small memory free. There's another requirement feature to run immutable infrastructure. So it's a Java with a container technology is not good enough to meet the developer and IT operation team requirement. That's the reason why Node.js and Go is a more good high density in the same work node in the Kubernetes cluster. So let's take a look at that. The Java with the lots of using heap memory, but Node.js Go is maybe twice and triple time high density rather than Java application with the same resource capacity. Another reason why more people move to develop Node.js Python to implement of the serverless application and function on top of the Amazon Lambda. This is a recent survey from the serverless benchmark report, Amazon Lambda 2020. So more than 50% is Node.js is a popular language framework and the platform to develop your serverless application. And also, uh, uh, as the serverless landscape standpoint, there are a lot of tool, framework, and platform is a manageable or managed platform. So the big concern from developer and operation team, like a DevOps team, how to find out the appropriate tools framework. For example, there are more than 7 to 10 million Java developers to develop enterprise application from existing one and new Microsoft application with the Java technology out there. And then they needed to optimize existing Java application to deploy a fast platform or serverless platform. In order to do that, they need to own tool and they need to make a choice which tool should be perfect to their Java technology. So as a result, it's too many choices. But Java has tried to improve itself, try to fit in more Linux container technology in terms of the memory utilization and CPU utilization. Also, there are new uh, garbage collector algorithm like a Shannon Doha, and then there are new process compiler for like a Darby for Android operation. There are lots of the huge effort to enhance Java technology to fit in the new IT trend like a immutable infrastructure and the Linux container and the microservices and it's a public cloud, etc. But still, that's not good enough. So that's why we needed something different with Java. So Quarkus unleashed upon the world just 1 year ago. And the Quarkus is a little bit more focused on enable Java developer to develop cloud-native application and microservices and serverless with the event-driven architecture as well as the traditional microservice architecture. So Quarkus really focus on optimize the center part. So microservices, serverless, and just start a millisecond with the native compilation, and then just under less than 10 memory footprint, like a 30 time less than or even 100 time less than memory footprint compared to existing cloud level Java stack. And you can also have two different runtime like a JVM, also GraalVM. So how does the framework start? In the meantime, so Java application in the build time, they needed to create the bytecode compilation, also known as the immediate code, and then intermediate code and the packaging using some tool like a Maven, Gradle. And there are spend a lot of time in this step to build application for developer. And then what happened when you run that application on your production environment, even your local machine, the first local try to load your configuration file and enable, disable some feature, and also try to parse annotation and processing descriptor and the build framework meta model and proxy, etc. In the end, you're going to start the actual application with the thread and pull. So from 1 to 5 step, it's not related to actual application startup. So how does Quarkus change that? So Quarkus makes a thin jar rather than the fat jar, and also you can have a native compilation feature with the Quarkus, which means that you print the all necessary task you can do that at boot time rather than runtime. So take a look at the right side, the runtime. You just need to start your application actually. So just like it's a cartoon, wait. So you just save it and your code is running and it's still Java? Yeah, that's cool. It's a supersonic Java. And that is Quarkus. So Quarkus enable compilation a little bit narrowed down. So first thing you need to compile to create the thin jar and the provision is created. And then you can run the JDA hotspot runnable image. And also you can have native compilation along with the ahead of time strategy. And in the end, you can have native executable file like the Go program language platform. And then you just run that application without JVM. So today I'm going to showcase Quarkus and Fungy to develop a serverless application, and you can write function with the standard portable Java API. So there are a lot of choices I already mentioned earlier. So you can develop Java, but you need to change some configuration, even some annotation to deploy specific serverless or fast platform. Uh, so this is a really big burden for developers. So they are maybe really prefer to some specific serverless platform like Knative with the Kubernetes or Amazon Lambda or Google Function or Azure Function or any other serverless platform. So Quarkus allows the Java developer to have a portable Java API that can be deployable any serverless and fast platform. This is a new strategy of the Quarkus application framework. So you can see here you can just deploy Quarkus application with the Fungy using HTTP protocol, and also deploy Amazon Lambda and the Knative event, and also HTTP with the Azure function and the Google Cloud Platform. I'm going to talk a little bit more about in the demo. All right, let's jump in the demo. How Quarkus help a developer to write the function for multiple serverless platform, including on-prem. Let's get started.
Okay, let's create a new application project using Quarkus tool on ID tool. And first of all, we're going to add the project group ID and artifact ID, and I'm going to leave the others by default and just generate the application code and some my temp directory. And let's take a look at that, the generated application code here. So this is a RESTful API, just endpoint, hello, and a return hello, very simple application. Let's try to make sure this application works properly, and just run the Maven command line and Quarkus dev mode, and it takes a couple of seconds to start up your Quarkus application here. Let's take a look at that. You have a CDI and a REST EG by default, and Quarkus provide a wonderful functionality to develop Microsoft's application here. And when you access the hello endpoint, you got the hello return code. And let's try to add another endpoint as your function here. In order to that, we're going to add a new CDI bin here. The name is the greeter service class name. And we're going to define new method. The name is greeting. We have some one parameter like a name. And return the text message such as welcome with the name as a parameter. And then for hybrid serverless development with the Quarkus. Just a simple text message with the parameter name, and just a simple just the CDI bins. All right, I think this looks good. And go back to resource file here and inject the CDI bin using inject annotation, and the greeter service here. The name instance name is service. And then just copy existing endpoint, and then we're gonna just try to tweak whatever we need. So path annotation, try to have a new endpoint greeting, and with the parameter name, and this will be a new function method here. So, but in proper to do that, we're gonna just implement a new Microsoft's application endpoint using REST API on Quarkus, and then just invoke greeter service with the greeting using parameter name. All right, looks good. And just try to access the new endpoint here, the hello dash greeting and the name, let's say Daniel. And the Quarkus automatically repackage, rebuild, and restart your application automatically. This is really fantastic for developer. Okay, that's really cool. So let's try to convert this application as a function. In order to that, we're going to use a Fungy, one of the Quarkus extension. So just add a Fungy annotation here, and then, but your Quarkus runtime still running on top of that, and then we just use a Fungy annotation here. Once you use a Fungy annotation, you don't need to use the pass annotation any longer. And then the the function name is a method name by default, but you can also define your specific function name, such as hybrid in this case. So, and you can still use the parameter and CDI bins here, and then we're going to delete unnecessary import here. The your application code is pretty simpler than previous one. And let's try to access the hello endpoint to invoke your function. So now you're gonna the hello the same result here, and then let's try to another function like greeting as a post method here, and the parameter Daniel O in this case. So HTTP and the post method, and we're gonna use 8080 port, and the endpoint is a hybrid. Okay, so we got a result hello Daniel O for hybrid serverless development with a Quarkus. Pretty awesome. So you can package this application, deploy Kubernetes native, the Knative serverless. But for that, we're gonna package this application as a native executable file using native compilation. This is one of the beauty of the Quarkus, to packaging your application to fit in a serverless platform or a fast platform, because it's super fast and small, tiny memory buffering is a pretty effective way to manage your serverless application or function on top of the Kubernetes cluster, even manage the fast or serverless platform. It takes normally a little bit longer than general Maven packaging to create a thin jar, because once you packaging thin jar, and then you need to add all dependency to create the executable file. And after that, you don't need to execute this executable file on top of the JVM, but instead you just run this executable file on top of the VM. So this is the using ahead of time strategy I already mentioned earlier in the slide stack. So this, you have still two options to deploy your Quarkus application and microservice application on top of the Quarkus using ThinJar or running on top of JVM, also executable file on VM. All right, so run this application, just execute with that file, but here is we just needed 34 milliseconds to start off. It's super awesome. Just imagine when you run this application as a function on top of serverless platform, it's pretty awesome. And then let's try to deploy this application. I already packaging the container image like a Docker, and also push it into external registry. And in order to deploy this application, I'm going to use the container platform 4 and create a new sample project hybrid serverless, and I'm going to pull down external registry such as Daniel O and hybrid serverless and raise tag. And then once you need to do is to select Knative service, which means OpenShift deploy this application as serverless using Knative project. And then your application will be start. Oh, it's already start up. You just need the 7 milliseconds to start up, and just so you can change the label, like application OpenShift IO runtime equal Quarkus, which means you can show this pod is based on Quarkus compared to the other application pod. All right, let's try to access the endpoint, like a first function endpoint, hello. Okay, we have the same result as a local machine. And then the next, the other function is greeting. But for that, I'm gonna readjust the browser size to show at the same time to call endpoint here from my ID tool here. I'm gonna create a new terminal here, and just using same HTTP command line, but in this case, I'm going to use a route URL in OpenShift Container Platform. Just copy that from web browser and paste it here, and now let's try to make sure endpoint hybrid here. And now let's try to wait to scale down to 0 automatically as a part of the feature of the OpenShift serverless operator. And it will goes down in a second. By default, 30 seconds will be scaled down to 0. Okay, it's scaled down and just involved endpoint, and the pod is automatically start up, and then we got the same result. But it takes just 1 or 2 seconds. That's why the Dev compilation is a really cool option to build and deploy your Java application. All right, next step is let's try to deploy the same application, different serverless platform, such as Amazon Lambda. All right, in order to that, we're gonna add another Funky extension here. So add a new extension and try to search in Funky, and here is a Funky Amazon Lambda, and there is a Google Cloud function as well. Well, in this case, we're gonna use Amazon Lambda Funky extension here. So once you add your extension here, and then we're gonna add one property file, the Quarkus Funky export is a function name. So for example, hybrid. In order to deploy to Amazon Lambda, we're gonna deploy the one function at one time. Let's try the packages application. I'm going to skip the unit test because the unit test expect the return code hello. But we're going to change that multiple endpoint at the moment. And then once you package your application and you go to target 3, there are generated some YAML file. You can run that thing on your local machine using SAM CLI, and also there are bash script to deploy your application using Amazon Lambda CLI to remote Amazon Lambda. Let's try to go to Amazon Management Console here, and we're going to use the IDM, the Amazon resource name, and I actually already created one role to deploy this function, Quarkus application here. I just copy my airline role here, and then just go back to Amazon Lambda, and then just make sure there's no function at this moment, and then just edit that the Amazon role ARN name in a manage bash script here. Just to run this bash script with the parameter create or delete. So in this case, we're going to create the new function based on this application onto Amazon Lambda here. It takes a couple of seconds to deploy your application. Okay, we got a successful return code here. Let's go back to Amazon, the management console, and reload. Okay, we got a new function here. Let's try to test this application, and in order to that, we're going to configure test event. Let's say event name greeting and the parameter name like my name Dan O in this case, and I create the test event and I invoke the test. Just expand the detail. Okay, welcome Dan O for hybrid serverless development with a Quarkus. It's the same result, and then let's try to delete this function. Once you test and you don't need to use that function anymore, you just the same bash script, just delete, and your function will be automatically deleted, which means you don't need to worry about the building. And let's try to call different function like a hello, and we change that. But when we repackage this application, the manage bash script will be generated once again, which means the ARN name will be deleted we defined previously. So you can also parameter that role name when you run the bash script here and try to create once again to deploy this Quarkus application as a function onto the Amazon Lambda. Okay, it takes a couple of seconds to deploy new function hello to Amazon Lambda. All right, we just got successful message here. Go back to here and reload the page, and we got a new function here. In order to test the event name, let's say hello, And then the parameter, there's no parameter, just the nothing parameter, and then create that thing, and then just click on test. And the detailed result, and here is a hello, just like we did in a local environment. And also there are more Quarkus extension with the Funky here. Go to quarkus.io and then click on guide and then search the Funky, and you can find that here's a Funky HTTP application, and you can have a multiple extension to deploy Quarkus application as a function. Use your Funky extension here, Amazon Lambda, and the Google Cloud function and Azure function using HTTP. And also you could deploy Quarkus application as a function using Funky and Knative event. You can integrate Knative event like a backend, PubSub, Kafka messaging, etc. All right, let's go back to slides there to recap.
The Quarkus, aka Kubernetes native Java stack, that enables Java developer to develop Kubernetes native Java application. Because Quarkus is a little bit more focused on container first technology, which means container Quarkus optimized Java stack and make it very efficient for container and cloud and serverless with tiny memory footprint consumption and super fast startup time and response time. And also, as you already saw, Quarkus provides a live coding functionality, which means you don't need to rebuild, packaging, restart your application runtime during the year change the code. This is really awesome for developer. In the end, this feature increase developers' productivity. And also, Quarkus enabled the developer to have imperative and reactive application at the same time using different annotation. For example, you can add inject for CDI bin or pass annotation to expose RESTful API, just like imperative traditional Microsoft application development. But also, you can add streaming or incoming, outgoing annotation to interact the backend Kafka messaging server. And there are a lot of extension. You already saw Funky extension, but also there are lots of extension like here. But still, the Quarkus is the Java, which means you don't need to worry about the steep learning curve to catch up new technology to develop new Microsoft application or serverless application on top of the Quarkus. There are lots of extension. You can easily add a new extension such as metrics like Prometheus and Jaeger and Carry, and then there are Keycloak and for single sign-on and micro profile, some Java Jakarta EE capability, and there are more and more enterprise and the open source community project is Quarkify to use for developer. And one and the Quarkus actually is part of Red Hat runtime portfolio. So Red Hat runtime provide the cloud native runtime such as Spring Boot and Node.js and Vertex and Quarkus as well with a fully support. So if you got if you're looking for the enterprise grade support when you use Quarkus to run your application in production, feel free to reach out to Red Hat sales representative to discuss more details. So if you're really more interested about how to get started Quarkus application development on your local machine or even your enterprise companies, there are three great resources here. The first one, the IDC lab validation to compare the performance with the other cloud native Java stack, and also their interactive self-service portal training website. Just go to bit.ly/try-Quarkus. There are lots of practical scenario you can go through by yourself. And once again, code.quarkus.io is a starter. You can generate any application from scratch and put in any extension to have your application capability. All right. Thank you for joining this session. And now, Q&A. If you have any question and any curiosity of the Quarkus and serverless, please put on your question on the chat box, and I can ask that. And have a good rest of the day.